sheet here. So we'll start with A. I'll just do them right on this page here. So when I rationalize a fraction, remember you need to multiply the fraction by that fancy 1. And in order to do that here, what's the fancy form of 1 we would multiply this fraction by? Radical 19 over radical 19. Right? We want to rationalize, which means get the radical out of the denominator. So here you multiply straight across the numerator. 8 times radical 19 is 8 radical 19. And what was the trick we learned? When I multiply the same radicals together, it just becomes the radicand, the number underneath, which is 19. And 8 over 19 does not simplify, so this is your final answer. That one's pretty easy, yes? All right, the second one is also really not that bad, but you have to do a lot of simplifying to start. So I'll just erase these last two. To start B, you first have to simplify the original fraction. So this becomes radical 64 over radical 12. Can I simplify those two radicals? Yes, what's radical 64? 8. And does radical 12 simplify? What is it? 2 radical 3. So you don't have to simplify that from the beginning, but I think it's easier to simplify the radical 12 to 2 radical 3 to start. Because now when you rationalize, what are you going to multiply this fraction by?
2 radical 3.
No, you don't have to do the 2, just the radical 3. Just the radical, that's all we want to move. So I multiply by radical 3 over radical 3. Now the numerator is pretty easy. I get 8 radical 3. The denominator, I have a 2. Oops. That coefficient of 2 stays there. But what's radical 3 times radical 3? Radical 9. Radical 9 equals 3. So really my denominator is 2 times 3, which is 6. So you have 8 radical 3 over 6. And does 8 over 6 simplify?
Yeah.
Yes. Or not over 4 over 2. 4 over 3. So we become 4 radical 3 over 3. Which is, so that one's hard only because there's a lot of simplifying. Right? 8 divided by 6. Divide them by 2, and it's 4 over 3. Everybody good on that one? Makes sense now? Last one here. You have to use that thing called a conjugate. What is the conjugate of 10 minus radical 3? 10 plus radical 3. So in order to rationalize these more complicated looking ones, you need to use the conjugate. Now when I multiply the numerator, it works out pretty nicely. I have 1 times 10. Shh, guys, listen up please. Which is 10. And 1 times radical 3 is just plus radical 3. That's my numerator. The numerator is pretty simple. The denominator, in order to multiply these, you need to distribute. So my suggestion was you put parentheses around each set of denominators so that you can remember that you have to distribute or FOIL here. So when we do that, I have 10 times 10, which is 100. 10 times radical 3, which is plus 10 radical 3. The inner part here, minus 10 radical 3. And radical 3 times radical 3. It's radical 9, which is 3. Remember, it's always the number underneath. So we have a minus 3 because it's a negative times a positive. What always happens when we do these special conjugate ones? The inside part cancels off. So I really have 10 plus radical 3 over 100 minus 3, which is 97. And that's it. Okay, so a little bit more complicated. But this is similar to your quiz for tomorrow. Your quiz for tomorrow, I think, is just 3 questions. I don't think there might be 4, but I think there's 3. Similar idea, rationalizing, understanding conjugates. There will not be I on your quiz tomorrow. Do we have any questions on the homework problem with the I? No? Okay. Any questions on any of the homework in general? All right, so if not, you can put that away. We have 2 functions. We're going to start with this first one. It says f of x equals the square root of x. Now they want us to graph that function without using our calculator, just using our brain. So let's think about numbers that we can put in here. If I put 0 in for x, I need to find the output if I put 0 under the square root. And what's the square root of 0? 0. So the point you would plot is 0, 0. So that goes right there. That's easy. How about if I put 1 in for x? You have y equals the square root of 1, and the square root of 1 equals 1. So we plot the point 1, 1. Okay, well, what if I put 2 in? Can I get a nice number when I take the square root of 2? No, what about the square root of 3? Square root of 4? Yes, so if I did the square root of 4, what would my output be? 2. So I go to the point 4, 2. All right, what about 5? Does it work? 6, 7, 8, 9 does. Y equals the square root of 9, which would give me an output of 3. So those points, actually, when you connect them, that makes the function y equals the square root of x, which is our parent function for the square roots that we're going to be working with this year. So it's kind of like a sideways half parabola. But same idea as the parent function before, the same pattern, just tipped on its side. Now what we're going to do is we're going to graph the second function now, square root of x plus 3 minus 2, without using our calculator, but remembering our rules from a couple units ago. What does the plus 3 under the square root do to the graph? Left. So we're going to take that pink graph and we're going to move it left 3. And what about the minus 2 on the outside? Down 2. Right. They're going to start coming back today. So I'm going to take each of these points. I'm going to move them left 3 and down 2. So you just take each point that you already plotted and shift it over. And once you connect those, that purple graph you can label as your other equation. So all of those same transformation rules are going to follow us the rest of the year. And, like it or not, they're going to follow you into pre-calculus and into calculus. You're going to be graphing trig functions, which are like squiggly like this, with all those transformation rules. So they will stick with you for a while. So we might as well do some square root graphs while we're at it. Now let's talk about domain and range. We've done domain and range all year, but let's talk about it in relationship to square root. So let's start with the parent function, the pink graph that's on my grid. First, let's find the domain and range by looking at the picture. So if I look here at my pink graph, where's the leftmost x value? 0. Okay, I'm going to use interval notation. So I'm going to start at 0, and it goes to the arrow on the right, infinity. So I'll have 0 to infinity with a bracket. If I did my range for that pink graph, where's the bottom y value? 0, and the arrow goes up to infinity. All right, that domain and range is easy. Now let's think about all the way back to September. Unit 2. We did domain of square root functions. So when I say to algebraically find the domain of this graph, that means I want you to look at the equation up here. What do we know about square roots? Can I have a positive under a square root? Can I take the square root of 0? Yeah, I did it right here. And can I take the square root of a negative? No. Technically there's an I, but in the real number system, no. So remember the inequality we would write? We would take what's underneath the radical right here, that x, and what did I put in between that and 0? I used an inequality greater than or equal to 0, because all the x's that I put into this pink graph have to be 0 or bigger. That's the domain. Now normally I would solve that, but there's nothing left to solve. All right, does that inequality match the interval that we wrote over here? Yes. All right, now let's look at our purple graph. Where is the leftmost x value on the purple graph? -3. And that graph goes from -3 to infinity with the arrow. Okay. What about if I look at the y's? Where's the bottom y here? -2, and it goes up to infinity. Now I'm not going to ask you to find the range from an algebraic equation. But to find the domain from that algebraic equation, you're going to do the same thing. You're going to take what's underneath the radical, x plus 3, and you're going to set it greater than or equal to 0. Now, when you do that, you have to solve for x. So all you have to do is subtract 3 from both sides, and you'll get the inequality x is greater than or equal to negative 3. Now, does that inequality match the interval we wrote? Yes, the inequality says all these numbers greater than negative 3. All right, now, the notes kind of skip around. So I'm actually going to have you flip the page, and then we're going to flip back. But let's flip the page to example 4 here, real quick. We'll come back. Now here, I just want to kind of stick with domain, okay? Yeah, okay. Oh, that's okay. I'm going to stick with domain here for a second. So let's talk about domain, then we'll go back to graph. So same kind of thing that we were just doing. Let's jump right to B. Okay? If I want to find the domain of the square root of 8 minus 2x, I start off the same way I just did. I take the radicand, and I set it, what symbol? Greater than or equal to 0. So I'm going to solve this. This is just review. This is nothing too horrible. And I'm going to subtract 8 from both sides. When I do that, I get negative 2x greater than or equal to negative 8. Now, when I divide by negative 2, what do I have to be careful about here? I have to flip the sign. So I get x is less than or equal to 4. Now, the directions also say, I didn't read it, but it says write your answer in set builder notation. What does that mean? Curly brackets. So you can just stick your x and your bar and your curly brackets right around the inequality that you found. Okay? So this is cycling back. This is not new here. This is what we did way back in September. Right? This was a long time ago. It was Unit 2. We did domain and range. It was a long time ago. All right, now, let's actually, we're not going back yet. We're going to skip again. I don't know. It wasn't organized. I changed my mind once I started teaching it. So we're going to skip down to the very bottom of the page. So we're still out of order. We'll come back to all the graphs. Let's look at 6. So who loved quadratic inequalities last unit? Oh, that's a sign of love right there. That's the sign of love. We're going to bring back quadratic inequalities to help us find the domain of this problem. Now here's how we're going to do it. We have to find the domain of the square root of x squared plus 4x minus 12. Okay? And I would make sure you pay attention here because this is bound to come back and follow you. So the square root of x squared plus 4x minus 12, I start off the same way with domain. I take the radicand and I set it greater than or equal to 0. Well, that right there, what does it do? Does it bring back pain for you? Hope not. But it hasn't been that long, so maybe we can remember what we have to do. What do you think I need to do to solve that inequality? Factor. I will split the middle. I'm going to have 2 factors here. It's x squared, so I can jump right to factor form. I need 2 numbers that multiply to negative 12 and add to 4. 6 and negative 2. Solve x plus 6. X minus 2. All right, that's good. What do I get from that factored form? I get a root at negative 6 and 2. But here's the thing. My domain that I've been looking at in this last problem up here was written as an inequality. And I don't really have an inequality for my, I don't have like x is greater than something, x is less than something yet. So I need to use our knowledge from last unit to now make a graph, a parabola. So we're using a parabola to solve a square root problem. But we need to make a picture so we can visualize what the domain is actually going to be. So what my suggestion is you plot those 2 points. Just sketch them. They're not going to be pretty, but sketch. Yes, Janie?
What if x is greater than or equal to 6 and not equal to 6?
Well, those are the roots. You could use this symbol. Like, remember when we did the quadratic inequalities, we said these, it doesn't really matter what symbol you use here with 0 because you're going to plot them anyway for the x-intercepts. Maybe. Let's go with it. I found the roots. Now, I have to sketch a parabola here, because that's what I actually have. I have a parabola, and I want to know where the parabola is greater than or equal to 0. So is my parabola going to open up or down? Why? Because this is a positive x squared right here. So I'm going to have to sketch a parabola that opens up right here. And when I look at that parabola, I want to know where it is greater than or equal to 0. So does that mean above or below the x-axis? Above. How many parts when I look at this graph are above the x-axis? 2. These left parts right here. Now let's think about last unit. If I had greater than or equal to, what kind of dots would we have used on the number line?
Solid.
Solid. Close. So I'm going to draw a number line right on my picture here so I can visualize it so I can jump right to my domain. And close dots there. If I have 2 parts shaded, do I go out or do I go in? I go out. So I would bring my solution set out, left and right from there. Now I know this is a lot of work, but now I know my domain. I know that my x's for my domain, what inequality goes on this left part right here? X's to the left, less than or equal to -6, or x's greater than or equal to 2. Okay, so that's actually my domain for this square root function. I have all the x's that are smaller than -6 or equal to, or 2 and bigger. Now what I want to do is, we don't have our calculator, but we're going to sketch what this graph looks like based solely on the domain. Right? Now we haven't seen a lot of pictures of square root functions, but at least we do know at least a couple of them here. We know that they kind of look like a half sideways parabola. So at least we kind of know the shape of it. So you can trust me on this last one here. So here's what I want you to do. We know that we have one inequality. This is x is less than or equal to -6. So I want you to go to -6 here on your number line. Put a dot. And that part, that left part of your graph, is actually going to look like a square root function going off to the left. And then this other part of the graph is going to start at 2, and its part of the graph is going to be a little square root function going to the right. That's what the graph looks like. That's the square root of x squared plus 4x minus 12. Okay, so it's a little funky looking, but it kind of makes sense. So all these numbers that are in here, that are in between, like the empty part of the graph, those are the x values that are not in the domain. So for example, if I went to like x equals 0 right here, if I put 0 into the function, so if I had the square root of 0 squared plus 4 times 0 minus 12. What does that simplify to be? The square root of 0, 0, minus -12. Is that a real number? No. Sorry, I didn't write it very neatly. Well, since it's not a real number, that's why that number is not in the domain. That's why there's no graph on those values. Okay, so that's why the graph goes that way. Wasn't that great?
Yeah.
Yeah. There's going to be more of those on your homework, practice quizzes, all those kind of things. So make sure you understand. It's not gone. Quadratic inequality. Now you can go back to the front of your notes. Sorry for jumping around here. Sorry for jumping. We're done with domain for a few minutes. Well, not really, but kind of. Done with domain algebra. Let's shift back to transformation. So I look at this square root function here. What looks like happened to it? What transformation? It reflected over what axis? Yeah, so it reflected over the x-axis. What else happened to this graph? It looks like it went left. And it looks like it went left 4. So what happens to the equation when you reflect over the x-axis? It is a negative. In front or underneath? In front. So right now, all I can do is cross off C. That doesn't have a negative. The rest of them all do. What about left 4? What characteristic is that? Plus 4, under or outside? Underneath, which would match what equation? A. So A is the equation for that. So once we do a few of these, all these rules will start to come back into your brain. Now let's take a moment and let's write an equation of the square root given a description, and then we'll do some graphing to finish up the day. So I'm going to write an equation with the square root in it of a function that underwent a vertical stretch by 4, a reflection over the y-axis, and shifting 8 units down. Okay, so it says y equals. How do I do a vertical stretch by 4? What does that do to the graph or equation? Where I use a 4. Where does the 4 go? Under the radical or outside the radical? In front. A 4 or a 1/4? A 4 for vertical. If this was a horizontal stretch, what would it do? What would be a 1/4 underneath? We're not doing horizontal, we're looking at vertical right now. So I have a 4 in front. How do I reflect over the y-axis? Negative under the radical, so a negative x. And then shifting 8 units down would be -8. Make sure the -8 is not under your square root. Okay? Okay, starting to come back a little bit. All right, now let's look at that graph, example 5 now. We're going to make 3 graphs. Now these graphs, I want you to make sure you're paying attention because we're not going to use the multi-step graphing this time. Right, it's going to be make a graph. You can't use your calculator, so you need to make sure that you take things one at a time. I did put the parent function up above, so you can reference it for the notes here until you get comfortable with the parent function. Okay? So we're going to start with the function 3 times the square root of x minus 4. So let's first decide what happened to this graph. What does the 3 do? Vertical stretch by 3. So our graph's going to get taller. And the -4 on the inside. Right 4. Now, since we're doing this all on one graph, we're going to take it point by point, transformation by transformation. So we're going to start at the first point, 0, 0. That's the easiest one to transform. So if you start at 0, 0 right here, if I vertically stretch that by 3, does it go anywhere?
Yeah.
No. If I move it right 4, it does move somewhere, right? So you're going to move that point to 4, 0. So remember, vertically stretching only changes the y's. Now, if I go to the next point, 1, 1. I start at 1, 1. When I vertically stretch it, where does it go to? It moves y through the x's. The vertical. Y. So it moves you up to 1. No. 3. Vertically stretch means multiply by 3. So I moved us up to 1, 3 here. And then right 4. 1, 2, 3, 4. So now that point is at 5, 3. Then I have the point 4, 2. If I'm at 4, 2 and I vertically stretch it by 3, my new point's at 4, 6. And then I move it 4. So I'm at 8, 6.
How did you get 6?
For what? I multiplied the y value by 3. 2 times 3. I just try your best, pay attention here, but we have to know the rules. We have to know vertical changes only the y, not the x. So that's your graph. Are we okay so far? We're going to do more of these. What's the domain of this graph? We can use interval notation. What's the leftmost x? 4. Okay, and that graph is going to infinity. All right, what about the range? What's the bottom line? 0. And it goes to infinity. Now, all of these, like the number part of my domain and range, should always have a square bracket because that point is included on the graph. Okay, so far? Let's try the next one. All right, the next one is negative 1/2 square root of x plus 6. So work left to right here. What do you see? What's happening? Reflect over the x-axis. Okay, what about the 1/2? Vertical or horizontal? Vertical compression by 1/2. So that means the y's are getting shrunk down by a half. And then the plus 6, up 6. Okay, so there are 3 things we are going to do to every point on this graph. When you start at 0, 0 here, so I start at 0, 0 and I reflect it over the x-axis, does that move it? When I compress it, does that move that 0, 0? No, because 0 times a half is 0. But then when I move it up 6, it goes to 6. Now use your pencil. Like when I did this, I like moved my pencil around, just like I'm doing with the pen here. If I start at 1, 1, if I reflect it over the x-axis, it goes to 1, negative 1. Right? We're down here now. I compress it by a half. So where will that point be? 1. Vertical compression is y. So I'm at 1 negative 1 half now. And then I move it up 6. 1, 2, 3, 4, 5, 6. So I'm at 1, 5.5. If you need to do more points and more graphs, that's okay. 4, 2. I start at 4, 2. I reflect it over the x-axis. I'm at 4, negative 2. I compress it by half, which moves me to 4, negative 1. I'm still in the negatives, and then I go up 6. 1, 2, 3, 4, 5, 6. So I'm at 4, 5 once I graph that point. All right, and then 9, 3 reflects over the axis. 9, negative 3. Where am I at when I compress it? 9, negative 1.5. Up 1, 2, 3, 4, 5, 6. So you're at 4.5 when you're done. Okay, so that one's kind of smushed up, and there's a lot going on there. But if you take your time, carefully think through x's or y's, you'll be okay. What's the domain of this graph? Where's my left x?
6.
Left x. 0. And we go to infinity. Now I want you to be careful here. Where's the bottom y value?
4.5.
No. There's an
Oh,
arrow.
infinity.
Negative infinity.
That's right.
I actually am coming from negative infinity, and I only get up to what y? I stop at 6. So here the endpoint's on the other side. Okay? One more, and then we're all set. Okay? All right. So let's try this last one. I have 2 square root of negative x minus 2. So what happens to this graph here? Vertical stretch by 2. The negative under the radical is a reflection over the y-axis, yes. And minus 2, down 2. Now on the notes, we didn't have any horizontal, but you do still need to know horizontal stretch compression. That's on the practice part, so we'll make sure we go over it.
That's what it's under.
Yeah, I can look at one in a second here when we're done. All right, now let's start at 0, 0. If I vertically stretch this by 2, does the origin go anywhere?
Nope.
If I reflect over the y, does it go anywhere?
Nope.
Nope, down 2 does. Plot that point. 1, 1. If I stretch 1, 1 by 2, where does that point go? 1, 2. I reflect it over the y-axis. I'm at negative 1, 2. And then I move it down. Negative 1, 0. So this graph, if you can visualize it, is going to go left that way. Okay. 4, 2. That stretches to be 4, 4, right? Reflected over the y-axis, negative 4, 4. Down 2. And finally, where does 9, 3 vertically stretch to? 9, 6.
9, 6.
I reflect it over to negative 9, 6. And down 2. So when I graph this, it's a little taller and it's going to the left. Now when I do my domain, what is happening on the left here? Negative infinity, what's the right endpoint?
0.
0. Okay. Now where's the bottom y value? Negative 2, and this goes up to just up. It's going up to positive infinity. Yeah. All right, now that's the notes for you. Now, I will say, if you look at the practice, we didn't really talk about horizontal here, so let me look at, like, number 9 on your homework. Okay, if you don't want to listen to this, that's okay, because it's not the notes, but it might be worth your listen. So number 9 on the homework, the very back here. If I look at 9, what is happening to this graph? We'll do this one. Okay, so there's a horizontal stretch by 2. What does that negative do? reflect over the y-axis, and the +3 moves it, boys. If you're not going to listen, fine, but don't talk over me. The +3 moves you up 3. All right, so let's go through this one together because the horizontal is a little bit different. All right, so if I start at 0, 0, if I horizontally stretched my origin by 2, does it go anywhere? No, we're changing the x's this time. I reflect over the y, that doesn't move it, but up 3 does. Okay, so I have a point at 0, 3. Right, that first point doesn't normally move a lot. Now, if I'm at 1, 1 here this time, if I horizontally stretch 1, 1 by 2, does the x value of 1 change?
Yes.
Yes, it goes out to x of 2. So I'm at 2, 1. Then I reflect it over the y-axis, so I'll be at -2, 1. Up 3. Okay, so you're at the point -2, 4. Make sure you got to -2, 4. Okay? What about the point 4, 2? If I horizontally stretch that, where does that get to be? Not the x value changes, so it's 8, 2, which is over here. Right? The x's change, not the y. So I'm at 8, 2, but the 8, 2 flips to the other side, -8, 2, and then I move it up 3. All right, so the y values stay the same. It's the x's that get spread out. So those are, we know we have to think a little harder there, but when I horizontally stretch, I have to multiply the x value rather than the tall, right? I'm going left and right stretching. Does that make sense for the graph? All right, then you can do the geometry. But does that help seeing that one there, the difference? All right, I'll put this video up later.